Hi all, this video is going to be about the homework that's of chapter 4 lesson 6, which is about AAS, ASA and HL theorems. So if you have understood the lesson, I can guess what the answer will be, but still you have to try to do this. Okay, so let's start by, this is question number 1 2 3. We have to follow this what's given here. Students in Mrs. Marquez's class are watching a film on the uses of geometry in architecture. The film projector casts the image on a flat screen as shown in the figure. The dotted line is the bisector of angle ABC. Now again I'm repeating, what does this word bisect means? Bisect means divide an angle in two equal parts. Bi means two, sect means part. So divide the angle in two parts of angle ABC, because they're talking about angles here. Tell whether you can use each congruence theorem to prove that a triangle ABD is congruent to triangle CBD. If not, tell what else you need to know. Okay, now there are three theorems which we learned in this lesson. One was ASA, right, which said the two angles and the included side, if it is equal, then we can use ASA. Another one is double AS. That means two angles and the non-included side are equal, two triangles are congruent. And the other one was the HL theorem, which said that in a right triangle, if the hypotenuse and the leg of one triangle is equal to the hypotenuse and leg of the other, then both the triangles are equal. So here they have given us the theorems. We have to say whether we can prove using the proof that these two triangles are congruent or not using these theorems. Let's see. Now, first one is hypotenuse leg. What are the things you need to use when you have a hypotenuse leg? There are two main things you need to use. First is the hypotenuse, and one is the leg. Right now, check in the information given. Have they given you if the hypotenuse is equal and the legs are equal? So this is figure ABD. This is ABD. So they're talking about this triangle. Now to make it clear, let me just draw around the figure so that you will not be confused. Okay. So they're talking about triangle A, B, and C. Should I made it a bit thicker? This is triangle ABC, and let me draw another one with another color so that, see, I am trying my level best to make you all understand. Hopefully you would understand by the end of the lesson. Okay, so you can see that there is a side overlapping here, so I'm drawing it like that. I also advised you during the explanation that better you always draw it separately so that you will not get confused. So we need to prove that this red triangle is equal to the green triangle. Now from the figure we can derive, if this is 90 degrees, this is going to be a 90 degree as well, because of the linear pair theorem, right? If the angles on a linear pair add up to 180, one part is 80, the other part is going to be 82. And then BD is going to be equal to BD because of the reflexive property. Now we are talking about hypotenuse leg, which means the hypotenuse should be given and the leg should be given. Now, look at the information. Did they say the hypotenuse? Hypotenuse is the longer side of the right triangle. Did they say this is equal to this? They did not give us the hypotenuse information, but the leg, yes, we can find out that BD is equal to BD, but they did not give us anything about the hypotenuse. So we cannot prove that these two triangles are equal. So we need to say no. It's up to you, however words you use. So I am writing, they said what else you need to know. So we need to know the hypotenuse. So you can say no, we need to know the congruence of hypotenuse, or you could even say no, you need to know that AB is congruent to CB. So not necessarily you need to write the exact words. If the idea means the same in your words, that's fine. Now let's find angle, side angle. Now first decide what are the three things you need to find in this. You need an angle. You need in fact two angles and the included side. Included side means the side joining both the angles. Let's find out. So look at triangle ABD first. They gave this triangle, sorry, this angle, and they gave this angle. So they gave two angles. So we have two angles. What about the included side? Included side means this should connect, both the angles should be connected. That's called included side. So can we find out from the figure that that is equal, the included side of both of them are equal? Yes, we can, because by the reflexive property BD is equal to BD. So yes, we can use angle side angle to find out this. This is how you need to plan how to solve the question. The next is angle side angle side, which means two angles and the non-included side, which means the line which does not touch the two angles. So again, referring to figure ABD, we have two angles, right? Now the question says bisect, so it is also bisecting ADC, which means this side is equal to this side, right? Bisect means it's dividing even the line in two parts, not only the angle. If it's dividing the angle, it will also divide this line AC. So which means this line AD is equal to CD. So do we have two angles already said that they are equal? Yes, they said this and this is equal to this and this. So we are done with two angles. Now which is the non-included side? Non-included side can be AD or BA, right? It can be the non-included side. But BA, they did not give us any information. This is what we marked. So I'll erase that thing off. We marked that part because we needed the information, but they did not give us. So forget about the things which they didn't give you. But by the bisector, we could say AD is equal to CD. So this also we found. So there is an non-included side given. So you can say yes, angle side also we could use. The next question, which postulate can be used to prove the pair of triangles congruent? Now, these are, as soon as you see, you just guess what is the triangle, which are the triangles given. Here two right angles are given. So directly you could use HL, but to use HL, you need the hypotenuse and you need a leg, the measurement of a hypotenuse and a leg. So check if they have given you the measurement of hypotenuse and leg. Now, which is the hypotenuse of this triangle? This one. So by nature, we know that it is equal, right? They don't need to tell us this, we know that. But did they give us the legs are equal if any one leg is equal? Yes, they did. They said this leg is equal to this. So we could use hypotenuse leg theorem for this. Okay, because if you want angle side, we don't have two angles. They did not give us any two angles, so you can't use that. Same for angle side angle, we need two angles, so they did not give us. Let's try this out. Here they gave this angle is equal to this, sorry, this angle is equal to this, and they gave us this. So by nature, by like our common sense, we could say that this angle is also 90 degrees because they're linear pair theorem, right? So we have two angles. Now if you have two angles, they have given us two angles, right? Find out whether they gave us the included side. Included side means the line which is joining both of them. Yes, we could say that this is equal to this. Now we have done many questions like this. The line, the segment which both the triangles share are equal by the reflexive property. So we could say that we can use ASA, because if I use AAS, that means this will include the non-included side. This has the non-included. Which are the two non-included? This and this. They did not give us in the triangle that any of them are equal. So we have to use ASA. Fine. Let's move to this. Here they gave us this angle is equal to this and this side is equal to this. Now by the things we learned, we can only say this is equal to each other. So which formula is that which we have only one angle and two sides? There is nothing in this lesson particularly. We did not study anything. They are only referring to this one. Okay, so we could say it is SAS, but we cannot say even SAS because it should be two sides and the included angle. So they did not include the angle, so we cannot say. We have no theorem here, so we say we cannot prove this. None of the theorems have this, which is like two a non-included angle and two sides. No, we don't have any such theorem. Okay, here now, this angle and this angle, so that means these two angles are given. Now the included side is this and this. Did they give us that these two are equal? No, they did not give us. By the things which we learned, we say that this common part which both of the triangles shape is equal, right? So which theorem are we going to use here? We have two angles, and this is the non-included side, because included side means the one which joins both the angles. The one which doesn't join the angle is called as the non-included side. So we could say it is AAS, double AS. That's all. Just that you need to separate the triangles and think a bit. You can get the postulate or theorem, whichever they're asking for. All right. Let's do this. Write a paragraph proof. Now, when you see this word paragraph, do not panic. It's the same one, only that I showed you how to write in points. Now they want you to write it in a paragraph. That's all. We are going to write the same thing. Okay. So we start from the given information. What have they given? PQU. PQU is congruent to TSU. So they both are congruent. Angle QUR and SUR are right angles. So this is also a right angle. They have given us the information. So we have to prove triangle RUQ. That is, this triangle is equal to RU. Yes, we need to prove this triangle is equal to this triangle. All right, so let's start. So we can say angle, we are talking about only this part, so we don't need this. So let's start. Maybe they gave us this because we need to find this part. So if they both are equal, yes, these two are equal, right? That means these are also equal. These are going to be equal. How do we know that? These are angles on a straight line. These are supplementary angles, right? So if one of the angles is, for example, say it's 100 degrees, so the remaining part is going to be 80. Same here, if this is 100, this is also going to be 100. So this is also going to be 80. That's why they gave us the information. Okay, so let me just mark this. So because angle PQU is congruent, angle TSU is congruent, so angles QUR and SUR are right angles. So let's say this. Let's start by writing the given information first. So they have given us triangle PQU is congruent to triangle TSU. So you're going to write a paragraph. So that means you have to include verbs and conjunctions, all these things. Okay, so triangle PQS is congruent to triangle angle TSU is the given information. So before we used to just write given. So here we are writing is the given information. So angle RQU is also congruent to angle RSU because of what? They are supplementary angles, right? You just need to write it in a paragraph form. Because they are supplementary, you can just write they're supplementary. Okay, now again, we have proved that two of the angles are equal. This angle is equal to this. Now, I can also say this angle is equal to this, right? Because they are right angles. So I can say that already they have given angle QUR and SUR are right angles. So what does that mean? Angle QU1 and SUR are right angles from the given information. So you can write are already given. So angle QUR and SUR are right angles. Therefore, now framing a paragraph in math is, therefore, angle QUR is equal to angle SUR, which is also equal to 90 degrees, because as they are right angles. Now definitely your explanation and my explanation might differ, right? But the idea needs to be the same. So we have proved now two angles are equal to the two angles on the other side. Now we need one side. So either we have to say it is this side, that is the included side, but they did not give us any information about the included side. But by experience, by learning, now we know that RU is equal to RU, right? So you could say RU is congruent to RU by the reflexive angle, by the reflexive property of congruence. So we already have two angles and a non-included side. So which theorem did we use now? Two angles and a non-included side. We have used double AS, right? So triangle RUQ is congruent to triangle RUS by double AS. Now, if you have difficulty in deciding which theorem to use, just write down which are the three theorems you learned. You learned hypotenuse leg, you learned double AS, and you learned SAS or ASA. SAS was in the other lesson, right? So you have learned double AS and you have learned ASA, angle side angle. For hypotenuse leg, you need a hypotenuse and the leg. So here see, they did not give us the measure of any hypotenuse that this is equal to this. If they would have given us that any of the hypotenuse is equal, simply we can use HL and prove that these two triangles are equal. Because if the hypotenuse is equal to the hypotenuse of the other triangle, and if one of the leg is equal, it's easy to prove, but they did not give us this information, right? So double AS, yes, we did prove by using double AS. Now to use ASA, they need to give you two angles and the included side. Which is the included side? This side. They did not give us that information too. They did not say that the included side is equal to each other. So we could only use double AS to prove that these two triangles are equal. So hopefully this you have understood the lesson a bit better than previously. Try to do some more questions. If you have any doubt, you can ask me if the questions are sensible. Okay, so we'll meet again in the another video. Till then, if you have any doubts, you can practice or you can ask from me.